Okay, moving onward, we have a list of books which we will follow throughout this course. But obviously, I won't add all the topics from the books. I will make sure to add only those topics which are still in use and which are used by the industry. And I've seen many of the institutes, many of the top ranked institutes in the world, they are still using outdated knowledge from the books. But I won't do that. I will make sure to add the knowledge which is still in use, and you can make some benefits of it. And we'll be using unified modeling language, UML. You can use any software like rational.com or lucidchart, SmartDraw. These are some of the softwares in which you can draw UML diagrams like class diagram, package diagram, deployment diagram. And you can read more about the UML language on this link. And we will be using Java as a programming language while demonstrating all the design patterns and architectural styles, because Java is the most demanded programming language by the number of jobs. Here you can see in the top three, Java is there. And also Java provides greater support for the design patterns, and it is pure object-oriented language. So that's why I will be using Java for demonstrating different concepts of architecture and design. But you can use any other language as well if you want. Python or C++ can also be used, but I'll be using Java. Okay, understanding software design and architecture. Before we build a software system, we must first decide how it will be built. So that is the main question we should ask ourselves. What we want to build and how that would be built. Both are essential for creating reliable, long-lasting systems. Architecture shapes the big picture, the structure, the flow, the foundation, and design shapes the details, how each part behaves and feels. Both are essential for software system that last for decades. Titles may change across companies, but the responsibility remains the same. And great software is never an accident. It is thoughtfully designed. If you see Google, Spotify, Amazon, Netflix, Airbnb, or even Uber, so these are some of the software systems which you use daily, and these are not built by chance. In fact, they are properly planned, and their architectures are made so that if change comes in any of the system, so they can easily accommodate that change and without breaking the functionality of rest of the system. So we have to build a system flexible so that if any change comes in the system, so the existing functionality won't break. Okay, now let's talk about the difference between software architecture and software design. Before differentiating these two terms, let's talk about the real world analogy. For example, if you are building a house, so what would be the architecture of the house? The architecture of the house will include deciding the overall structure of the house, like number of floors, room layout, placement of plumbing, electrical wiring, and load-bearing walls. Now, what would be the design of the same house? Designing the details inside the house, like furniture, placement, wall colors, flooring, kitchen cabinets, and lighting. So these are what come inside the design of the house. Now, for example, you want to build a software system. So what would be the architecture of the software? For example, if the software is about online shop, so if it's an e-commerce store, so what would be the architecture? Architecture will include high-level structure like front-end apps, back-end services, product catalog, payment gateway, inventory system, databases, and third-party integrations, and how they communicate with each other. And the design of the same system would be designing the user experience and behavior, product pages, shopping cart flow, checkout screens, button placement, colors, fonts, and error messages. So these details will come inside the design of this same app, that is shopping app. So software architecture defines the structure and major components of a system, while software design focuses on the detailed behavior and user experience built on top of the structure. So software architecture is the bigger picture, while software design is the detailed view of that picture. Okay, now let's talk about the importance of software architecture, why it matters. Good design and architecture produces scalable, maintainable, and secure software that is successful. Good software is not a magic, it starts with a good design and strong architecture. When architecture is good, software can grow, it's easy to fix, and it lasts. That's how products become scalable, maintainable, and successful. But bad architecture is expensive. It leads to failures, slow system, and eventually full rewrites. Architecture is about alignment. What the business wants must match what technology can safely deliver. What's an example of a product that failed because of poor design or planning? Do you know any system that is failed due to poor architecture and design? Let's talk about the NASA's Mars Climate Orbiter that was meant to study Mars, but it crashed into the planet because of the software error. The failure occurred because one team used imperial units while another team used metric units for navigation calculations. This led to miscalculation in the spacecraft's trajectory. The mission failed and NASA lost the 125 million spacecraft. This incident highlighted the importance of clear communication and consistency in software development. If a building's foundation is weak, what happens over time? So this picture will answer this question. You can see two bridges. The one is having a clear architecture and design. The other one was not planned, and now the result is in front of you. So you have to properly plan your software system. Otherwise, your system will crash under little pressure.